Hi folks, welcome to day 1 of Advanced Algebra B. Hopefully you've already watched the syllabus video, and if not, I highly recommend going and do that. If you have, let's go ahead and get started on our notes. So, Advanced Algebra B starts with a review of polynomials. Now, if you don't remember, polynomials is poly, meaning multiple, alright, and nomial, meaning terms. So a polynomial is something with multiple terms, all right? So an example of that is something like negative 3x to the fourth plus 2x cubed plus 6x squared plus 7, all right? So you can see that it has more than one term in it, all right? Very basics. Now, polynomials are pretty cool because you can do lots of things with them. You can add them, subtract them, multiply them, and divide them. Now, depending on who you had for Advanced Algebra A, we put different emphases on these, or emphases, I'm not really sure. That's okay, though. That's why I don't teach English. So today we're going to start with a review of adding and subtracting, which is just combining like terms, as well as working with multiplication, all right, which is a lot about foiling, or if you had me before, you know that I call it a FMOIL, because there's a middle part. Something that we won't be doing this trimester is we're not going to be covering division, all right? It's great that you learn it in Advanced Algebra A, but it's not something that we're going to be focusing on. So today we're going to have this short video on adding, subtracting, and multiplying polynomials. So I'm going to go ahead and go through a couple examples. All right, so let's say we have two functions. All right, we have one function f, that's 2x to the fourth plus 3x squared minus 2x, and then plus 4. And maybe our other function is some g of x, which is 3x to the fifth minus 6x to the fourth plus 2x plus 4. Now, if you get worried about this notation f and g, remember, that's just like y, all right? It's just that that's function notation. So I'm going to first have us do addition, f plus g, all right? So remember, anytime you're adding polynomials, you're going to want to add like terms, all right? And then you're going to want to put them with the biggest term of x first. So if I go through and I look through, I see my f functions, my first one, has an x to the fourth term, an x squared, an x, and a constant. And my g term has an x to the fifth, an x to the fourth, an x, and a constant. So I can see that x to the fifth, right? That's my highest power of x, so I'm going to write that first. Now, there's no other x to the fifth, so I can't add anything with it. So I have 3x to the fifth as my first term. Then I'm going to look at my next term. All right, so since I already looked at x to the fifths, now I'm going to look at x to the fourths. Now, I can see with these, I have 2x to the fourth with my f term and a negative 6x to the fourth with my g term. So then I say, oh, okay, well, 2x to the fourth minus 6x to the fourth. Right, because I'm adding them, so plussing a negative is just like subtraction. Now remember, since we're combining like terms, all we have to do is say, okay, we have 2 minus 6, so we get negative 4 x to the fourth. All right, the x to the fourth just comes along for the ride. You don't have to worry about it. You don't have to like add the exponents or anything like that, because all we're doing is combining like terms. All right, so we get 3x to the fourth, or sorry, 3x to the fifth, minus 4x to the fourth. Then we're going to look at our x cubed terms. We don't have any, so then we look at x squareds next. I see one x squared term in my top function. My bottom function doesn't have an x squared term. So then we have 3x squared just comes along. All right, it doesn't combine with anything because you cannot add an x squared and an x, or an x squared and an x cubed. They're not the same power of x, so you can't add them because that's, remember, an x squared is like x times x. It's multiplying. Then we're going to go ahead and add our x terms. So we have a 2x up top and a 2x on bottom. So we get 4x. And then last but not least, we have 4 plus 4 gets us a plus 8. I know that's kind of on the side of the screen, but that's okay. So if we're adding f and g, you get 3x to the 5th minus 4x to the 4th plus 3x squared plus 4x plus 8. You can see that there's only one term of each type. You should not have in your final answer more than one term of each type, meaning you should not have a 2x and a 2x. You should just combine them into one term. So that's how we add these functions. Let's go ahead and take a look at what that would look like. Same two functions, but instead we do f minus g, all right? So for this one, when I underline things, I'm going to use reds and pinks and oranges. So if we do f minus g, all right, what we're going to want to do is I always recommend writing this out linearly. So that means like horizontally. So we have 2x to the 4th plus 3x squared plus 2x plus 4 minus, and then in parentheses, the entire g function. So all of this has to go in those parentheses. So we have 3x to the 5th minus 6x to the 4th plus 2x plus 4. The reason why we want to do this is because that way we remember to distribute that negative sign. All right? I know lots of y'all, if I had you last trimester or trimester 1, you forget to distribute that negative. That is a huge thing in math. Make sure you're distributing that negative. So then we get, whoa. So we get 2x to the 4th plus 3x squared plus 2x plus 4. So I didn't do anything with the f term yet. Now I'm going to get distributed in my negative, so I get negative 3x to the 5th plus 6x to the 4th, because you have negative times a negative, minus 2x minus 4. Now we combine like terms. So I have an x to the 5th term. I still don't have any other x to the 5th terms. So then, whoa. My apologies about that. Going back in, we get a negative 3x to the 5th. All right. Then we're going to look at our x to the 4th terms. So I have a positive 2x to the 4th and a positive 6x to the 4th. 2 plus 6 gets me plus 8x to the 4th. All right, because that's why you have to remember to distribute that negative, because otherwise your x to the 4th term would be wrong. Still no x cubed term, so I'm going to look at my x squareds. I have a 3x squared on one side, no x squareds on the other, so then I have plus 3x squared. Then I'm going to look at my 2x, or my x terms, right? So I have a 2x minus 2x, so I get plus 0x. And then 4 minus 4, so then I get it. And again, a plus 0. You could add in the plus 0 if you want. I'm not going to, but you could. So when we're subtracting them, we get negative 3x to the 5th plus 8x to the 4th plus 3x squared. But when we add them, you can see we get a longer term. That makes sense because you're adding. All right, so you should add on. It should be longer. Now, with multiplying, I'm going to do 2 examples. All right, so the first example with multiplying is if I have a monomial, like 2x to the 4th. Monomial just means one term, all right? And maybe my g of x is like 2x to the 5th plus 6x squared plus 3x plus 2. Now, if we're going to multiply these, f times g, all right, I get 2x to the 4th times 2x to the 5th plus 6x squared plus 3x plus 2. And again, the reason why I write these parentheses is that way I don't forget to distribute that 2x to the 4th in, all right? So otherwise, I know myself, I would forget. You as students might also. So if we're distributing in that 2x to the 4th, remember the nice part about this is that your coefficients, your numbers multiply. All right, so your numbers multiply, but your exponents add. Okay, so your numbers, the big numbers, your coefficients, they multiply and your exponents add. So when we do this, we're going to get 2x to the 4th times 2x to the 5th. 2 times 2 gets me 4. x to the 4 times x to the 5th gets me x to the 9, right? 4 plus 5 is 9. Then we have 2x to the 4th times 6x squared. So 2 times 6 is 12. X to the 4 times x squared gets me x to the 4 plus 2. 4 plus 2 is 6. All right, so that was that term. Then we have 2x to the 4th times 3x. 2 times 3 is 6. X to the 4 times x. All right, gives me x to the 4 plus 1, because remember, there is an implied 1 here. All right, I know some of you are going to be like, oh, no, there's no 1 there, right? That's just a 0. It is not a 0. It is an implied 1. If it was a 0, it would be a constant term, because anything to the 0 power is just 1. All right, so x to the 1 is just x. So when we distribute that, we have our x to the 4 plus 1 gets us x to the 5. All right, and last but not least, we have 2x to the 4th times 2. 2 times 2 is 4. X to the 4 times 1 gets us x to the 4. So you are left with 4x to the 9th plus 12x to the 6th plus 6x to the 5 plus 4x to the 4th. All right? So that was one example of doing a simple multiplication problem. That was just distributing in a monomial, one term. Let's go ahead and do an example when we have to do two terms. So our next example, let's say we have like x squared plus 2x. All right. And maybe our g of x is 3x to the 5 plus 4x cubed plus 2x. All right. Now, when we're going to go through and set this up, if I'm doing, again, f times g, what I'm going to do is I'm going to set that up like x squared plus 2x, because that's my f, times 3x to the 5th plus 4x cubed plus 2x. Now, this is when you have to remember that you're going to be foiling, all right? Or, again, if you've had me before, this is what I call FMOIL. Now, I call it FMOIL because there's a middle part, and I like calling it FMOIL because it reminds me that I have to do the middle part. So I'm going to have to take my x squared and distribute it to every single term, including this middle term here, right? Like this middle term is like what makes foiling and FMOILing different. So if we have x squared times 3x to the 5th, we have 3 times 1 gets us 3. X to the 5th times x squared gets us x to the 7. All right. Then we have x squared times 4x cubed. So again, 4 times 1 is 4. X squared times x cubed gets me x to the 5th because I add my exponents. Then we do x squared times 2x. So again, plus 2. X squared times x gets me an x cubed. Now I'm going to go ahead and do the exact same thing, but for my second term. So I have 2x times 3x to the 5th gets me a 6. X to the 6, because remember, this is an implied 1. Don't forget about that implied 1. So x to the 1 times x to the 5 is x to the 1 plus 5. 1 plus 5 is 6. Then we have 2x times 4x cubed. 2 times 4 is 8. All right, x times x cubed gets me an x to the 4. And last but certainly not least, we have 2x times 2x gets me 4x squared. All right, 2 times 2 is 4. X times x is an x squared. Now what we're going to want to do, because we're not done yet, remember, you're going to want to put into standard form. All right, standard form, if you don't remember, just means you're going to write the biggest power of x first. So I'm going to write my 3x to the 7 first. Then I'm going to write my x sixth term. So I have plus 6, x to the 6. Right, so that's my 7. That's my 6. I'm going to go down in descending order. So I go 7, 6, 5. Do I have any 5 terms? Oh, look, I have a 4x to the 5. All right, do I have any x fourth terms? Oh, look, I have one of them right here. So I have plus 8, x to the 4th. All right. Then I'm going to look for my x cubed. And x cubed is 2, x cubed. And then an x squared gets me 4x squared. So again, remember, standard form just means writing them in descending order. All right, Descending order just means biggest to smallest. All right, so writing them in descending order in standard form was the last piece that we had to do. If we had any like terms, we could have combined them. None of our terms were like terms, so they were all on our own. We didn't have to combine any. That's how you do addition, subtraction, and multiplication of polynomials. We're not going to cover any division of polynomials, but that's the basics for that. Go ahead and try out your assignment.